welcome to Home Learning Classes. Today we have discussion about another modulation technique that is known as single sideband suppressed carrier modulation technique. It is the continuous wave amplitude modulation technique in which the upper sideband or lower sideband means only one sideband is transmitted and the other sideband is suppressed from SSB-SC signal, and this suppression is achieved by using band pass filter. Means this modulation technique offers the transmission of only one sideband. It can be upper sideband or it can be your lower sideband. Due to this, it is known as single sideband transmission modulation technique. As per graphical representation, we have modulating signal. The modulating signal have maximum operating frequency f and it has the bandwidth b hertz. This modulating signal is multiplied by using product modulator with carrier signal, that is high frequency signal, and resulted we get SSB-SC signal. The SSB-SC signal has disadvantage. The SSB-SC modulated spectrum contains the modulating information twice in. It can be your upper sideband as well as lower sideband. So, in order to accommodate more number of channel in given frequency space or allotted bandwidth, we only provide the single sideband transmission, and this is achieved by using band pass filter at the output of SSB-SC signal. Now this SSB-SC signal is passed through band pass filter and resultant we get the single sideband suppressed carrier upper sideband signal or single sideband suppressed carrier lower sideband signal. Now you have the choice, you can go for the transmission of upper sideband or lower sideband, and this is represented in the figure. Now as per the outcome, we found that the bandwidth of SSB signal is same as the bandwidth of the baseband signal or modulating signal. Means by using SSB-SC modulation technique, we achieved 100% bandwidth efficiency, and this is the advantage of the SSB-SC modulation technique over SSB-SC modulation technique. Now we consider the mathematical time domain representation of SSB-SC signal. Here in this, we are going to find the time domain mathematical representation of SSB-SC signal. The main basic building block of SSB-SC signal are the sidebands. So we start our representation to calculate USB sideband or LSB sideband. Here we consider our given modulating signal, and its frequency domain representation is represented by capital MF. Now, if we multiply this modulating signal with unit step signal, that is UF, then resultant we get that is equivalent to MF into 1 by 2 bracket start 1 plus signal F. The UF is equivalent to 1 by 2 bracket start 1 plus signal F. Now we get the M positive F, which is equivalent to MF into UF, and finally it is equivalent to 1 by 2 bracket start MF plus J MHF, where MHF is the Hilbert transform of MF signal. Similarly, we get M minus F, and that is equivalent to MF multiplied by U minus F, and that finally equivalent to 1 by 2 bracket start mf minus j mhf. Now by considering m positive f and m negative f, we can get our upper sideband signal, that is x USB f, is equivalent to m positive f minus fc plus m negative f plus fc. Means if the m positive f is shifted to positive carrier frequency, that is fc, m negative f is shifted to minus fc, that is carrier frequency. So by utilizing m positive f and m negative f, we get the upper sideband signal, that is equivalent to 1 by 2 bracket start m f minus fc plus m f plus fc bracket close minus 1 by 2 j bracket start m h f minus fc minus mhf plus fc, and its representation is also shown in the figure. So by utilizing inverse transform for this above equation, we get the resultant equation of upper sideband SSB-SC signal, and that is equivalent to mt cos omega ct minus mst into sin omega ct. Similarly, we get the lower sideband SSB-SC signal representation, and which is equivalent to mt cos omega ct plus mst into sin omega ct. So, if we go for the general representation of SSB-SC modulated signal, then that is equivalent to mt cos omega ct minus plus mst into sin omega ct, and minus corresponding to USB signal or the plus sign corresponding to LSB signal. In SSB-SC signal, we have transmission of one sideband only. It can be your upper sideband or it can be your lower sideband. Now, very important point, MST is Hilbert transform of MT that will provide minus pi by 2 or minus 90 degree phase shift in every component of MT or modulating signal. So this is very important point that is required for the SSB-SC signal representation. Now we consider the mathematical representation for output side, that is receiver side. Here we get the received signal. Now the transmitted SSB-SC signal, which is corresponding to one sideband, it can be your upper sideband or it can be your lower sideband, is transmitted via communication channel and received at the receiver. So at the receiver we get the signal, that is mt cos omega ct minus plus mst into sin omega ct. The minus corresponding to upper sideband or the plus corresponding to lower sideband, and here we consider only one sideband for the SSB-SC transmission. Now, in similar way of DSB-SC modulation technique, to recover the original message signal from received signal, we utilize the synchronous detector. And in synchronous detector, we utilize the local oscillator signal. Now, this local oscillator generates a signal which must be exactly coherent or synchronized in frequency as well as in the phase with respect to carrier wave at the transmitter. And hence, due to this method of recovery of modulating signal at the receiver is known as synchronous or homodyne or coherent detection. So here we consider the local oscillator signal, that is equivalent to cos omega ct. So by multiplying this local oscillator signal with respect to received signal as per the block diagram of receiver, and this multiplication is achieved by product modulator. Now this signal is passed from low pass filter which have the cutoff frequency as per maximum operating frequency or bandwidth in the modulating signal. So at resultant we get our estimate of message signal which is equivalent to m.t/2. Now if we summarize the outcome of SSB-SC signal, then first we get the carrier signal frequency is suppressed in the spectrum. The second observation is that the baseband or message signal is present once in the modulated spectrum, that is corresponding to upper sideband or corresponding to lower sideband. The third observation is that MST is Hilbert transform of modulating signal by providing a -π/2 or -90° phase shift in every component present in the modulating signal. Now the another outcome is that the additional requirement of local oscillator signal which is completely synchronized with transmitter carrier in terms of phase as well as in the frequency, and this additional requirement which is meant due to synchronous detector at the receiver, making the receiver complex and costly, similar to our SSB-SC modulation technique. And another important point, the bandwidth of modulated SSB-SC signal is same as per the bandwidth of the baseband signal. And this is the important advantage of SSB-SC modulation technique over DSB-SC modulation technique. Thank you very much for your precious time, and please subscribe this channel for getting regular updates.